right? So because then then I have to keep repeating the things. I think with the kind of group which we have, I'm loud enough to reach out to everyone. So first of all, welcome to all of you. And I work with CSC, and Atin and me, we primarily, he looks after the waste department, and I look at sustainable buildings and habitat program. So we, rather you can say the people who really work on these subjects. So we'll be giving you a little brief of what we do here, exactly how this campus has been designed, what all features are there. But first, before I start, I want to have an experience, understanding from you. When you entered in this compound, or when you enter into any compound and you say, okay, this is good, bad or ugly. So what is that perception which brings you to that conclusion? So what do you think, what do you notice, what your eyes notice?
I mean, it's the nature.
So one is like green combination, or maybe the balance between the green and the constructed. Anything else?
I noticed one thing, that it should blend well with surroundings, even outside the campus.
Okay.
It should not look like a hurdle in surroundings.
Absence of AC machines.
Oh, that is
Absence of AC.
We are at AAETI, Anil Agarwal Environment Training Institute. This is situated in Nimli village, Rajasthan, Alwar district. And we are here for the next 4 days for the Anil Agarwal Dialogue 2022. And this campus is very unique, and what sets the campus apart from other campuses is its eco-friendly construction and the way the campus has been developed. And today we will be going for a guided tour of the campus and what facilities it offers, what kind of water recycling plants they have, and what kind of rooms they have, and the flowers and the trees, everything. Okay, let's move on.
So when you must have seen your flusher system, it's written that it's part of the wastewater system. So try to do not put these things in it. If you actually look at flushing systems also, onto either right or left side of it, you will find the star. If you look at this campus, this is roughly between 10 to 11 acre, right? So in this, 9% of the total land is touched, right? And that too touched in a way that we have not done any, we've tried to avoid as much disturbance to the soil as possible. So most of like central areas, the vegetation and everything is same the way it was there naturally. So when you design with nature and you know that water is going to be one of the important elements for you to look at, then you try to keep the native species more intact with you. So that's where Sunita ji called it an Aravalli miniature the range which she has built. So all the trees which are there in the forest, she studied those, and in fact the complete staff has done plantation in this area.
So it is not a patch on local surrounding.
Yeah. So we do have some of this. So what we have done is, before designing this project, so there was a study which was done extensively in this area to see what are the trees, what are the other features which we can incorporate. In fact, looked at one of the landmarks buildings around here to see what kind of stones or what is locally available. So materials which were there. So more you become local, what we say that sustainable is what becomes local, right? तो हम बोलते हैं एक हिंदी में कहते हैं भाषा भोजन भजन भवन और भेष, ये अगर लोकल हो गए तो सस्टेनेबिलिटी आ गया. तो उसमें एक भवन बहुत इंपॉर्टेंट है. So that has to come from the local materials and the characteristics which we have. So what we'll do is we'll take a tour, otherwise I'll keep standing and talking about it. Fruit bearing somebody was asking if fruit bearing nahi hai hamare paas. So this is all fruit bearing. So this particular side is all fruit bearing. So you see this is amla, then you have multiple species of all the fruit bearing are on this side.
This side.
These pink flowers are
Yes, maybe somebody from our gardening team will be able to tell you.
okay.
I think summer, seasonal, please. Seasonal.
Possibilities like this. I'm not a tree expert, that's why I said like somebody.
And what material has been used? I am also listening.
Construction is 9% of the total land, little less than that. So somebody was asking about air conditioning system, how it has been designed. So what we have done is we've looked at how the nature is giving us. So we mapped all the 4 seasons, the temperature, humidity conditions and all. What we realized that only 2 months in a year, when the humidity and temperature both are working against us, we require air conditioning. Otherwise, most of the time what we do is the first thing is natural suction of the air. So natural suction happens from here. A normal filter is there. A normal filter will be there in this cascade, right? So we pass this air normally to you. If the, like for example, in a current condition, I just need oxygen, but I don't need any of the, because temperature conditions, humidity, everything is perfect for you right now. So I will do filter this air and pass it on to you. There could be some kind of particulate matters and all, so I have to do primary filtration.
But no heating is involved.
Right now not, because the temperature conditions, everything is perfect for you. Then in case the temperature start rising and are still a dry, we are in a condition where the temperature rises and we are in dry condition, what we do is, we have, this is an evaporative cooling system. So what we do is we run water here. So this is something which is a 3-stage cooling system, which we call it, right? So you can take a zoom shot of this. So this is a 3-stage cooling, because most of the time in air handling units, you do not have evaporative coolers. So this is something, a new concept which CSC worked at, right? That I add a little bit of moisture and my job is done. Now in case after this, on those 2 months when the humidity is also working against me and temperature is not even to the range where I need, then I'll run through the chillers. So I avoid around 10 months are basically coming. So what we have done is almost 40 tons of the air conditioning requirement has been brought. Now this is one type of cooling system which you've seen. The other one I'll show you here.
What
does
is
this
the
get to
room
the
temperature you consider bearable?
Roughly, see, our human body temperature is at what? Anybody has any idea about what is our human body temperature?
97
degree.
सेल्सियस में बता दीजिए.
Celsius.
सेल्सियस में तो 98 बहुत ज़्यादा हो गया. उसमें तो बॉयल हो जाएगा.
25, 35, 37, 36 देखा जाता है.
Roughly, right? So now when you up till 32, 33 degrees, you should be comfortable, because the phenomena of exchange of heat is what? A surface which is more hotter will exchange the heat with the colder one, right? So this is according to the phenomena. Now if my problem is in our whatever construction which we do, we start kicking AC at 26, 27. Reason for that is because sometimes our third skin, first skin, second and third is my envelope, the building, the material by which I make it. The third skin jo hota hai na hamara, that is something which is not designed very well or is not tamed very well. So there we start losing thermal comfort. So when we start losing thermal comfort, we start bringing in artificial pump. So we have worked on the third skin. The third skin, we try to design it in such a way that it remains, the condition inside remains intact for a longer period, provides you comfort according to that. Try to utilize the nature. So everything which was available as a wedges before we utilize. Then finally, whatever is not possible, then these machines do.
So what is the lowest temperature which you create there, even in peak?
30.
So 28 is lowest.
Yeah. 28 to 30 is the condition lowest in the sense because there are one is an automation, one is our senses according to which we operate at. So sometimes you may get the range little between in this and that, but roughly we operate buildings between these two values. So we try to extend it also depending on the nature and condition and the adaptability of customer. Once we start getting complaints, then is the time but now I think the experimentation is quite over. We understand that you all prefer somewhere this as a temperature and the humidity condition, we operate accordingly. When you go back in your classroom, you will find a digital temperature as well as humidity meter is there. So those are like some of our sensors which is there. Like when you speed your car, you reduce the speed of the car is based on the sensory organs which is here. But machines do not have a sensory organ, so that's where either the human or our sensors will work and operate accordingly. So we are saying the air conditioning is fed through this. Now this air conditioner doesn't have any of the heat discharge in the environment. Most of the time आपके AC का एक heat पीछे को फेंक रहा होता है. तो आप क्या करते हैं? Heat coolth generate नहीं करते. Our systems do not generate coolth. We actually displace the heat from one to another. So what will happen is equity में क्या होगा? You are displacing a heat onto a poor who is living outside.
खान मार्केट के पीछे लेन से निकलना मुश्किल हो जाता है.
और अदरवाइज जो आदमी शायद नेचर में चारपाई लगा के खुश था, आपने उसका जीवन खराब कर दिया क्योंकि आप वो हीट जो है अब आप उसके ऊपर फेंक रहे हैं. Which he has not done anything. यही होता है ना, हम कहते हैं ना कि इंडस्ट्री हमें पोल्यूशन देती है, हमने तो कुछ किया ही नहीं, वो प्रोडक्शन करती है. सेम इज हमारे घरों में वही होता है.
Throw on someone's backyard.
So here what we do is we take that heat through the heat exchanger, put it into a boiler, give you hot water to the kitchen as well as the water which you are taking for a bath in the morning. So I'll show you the machine. So this is how the system has been conceived so that we do not even discharge anything into the waste heat also should not go into the environment.
Why these equipments are not on floor and but on
Vibration. So when the machine vibrates, your structural losses could be reduced. So we have to, the nomenclature is that you can't put the load and transfer the load onto the columns, not onto the beams, because the design of the structure is according to that. So these are some of the very interesting features, even our kitchen exhaust and all. As we keep telling industry that you should have wet scrubbers and all, the kitchen exhaust, everything has its wet scrubbers. So if for example today is cooking South Indian food, you're not able to smell anything out. Because the chimney, whatever the exhaust system which is there, so that takes care and filters that properly so that nothing goes into the environment from there. So any of your way.
What is the working of this? What is it?
This is basically the heat which is thrown out by the air conditioner through this exchanger plates. They exchange without contact, getting in contact, the heat is exchanged from this side to this side into the containers. So the water is stored as a hot water is stored here, which is given to you for bathroom.
Oh, wonderful.
So that's how the process works.
This is a brick structure or stone structure?
This is an aerated concrete. I was about to come on this. So when we started this structure, अब एक और चीज था, there was another the skin, the third skin, how we design. So when we started the construction, our original philosophy was to do the rammed earth construction. So that two structures are the first experiments for us.
I see.
So we wanted to do rammed earth construction, but because the binding capacity of the soil was not that great, so we were forced to add more cement and more cement. So then the decision was taken that in case I am adding so much of cement into it and then making it work, and then actually taking away the soil also, so it's better that I work on something else. So we have an AAC.
And it would not be multi-storied.
No, that is because these are fills. So when we do the construction these days, we have a tied structure.
Yeah.
So which takes care of the load and all. Then the walling materials or the walling assemblies are many times are not the load bearing elements now. Earlier it used to be.
Yeah.
Earlier it used to be when we used to make those 9-inch thick walls and all.
Yeah.
So now we do not have this. We generally, as per the code, you have to make a tight structure because of the earthquake and other things. And plus we don't know the ground. Many locations are now reclaimed land.
Yeah.
So you don't know the bearing capacity exactly
That's
mapped
right.
for it. So that's why now the code has been changed. National Building Code says to make a tight structure like this.
Yeah. Okay.
So that is why this structure has been made, considering all the environmental and the temperature conditions, behavior throughout the year. So we designed our third skin according to those.
These
So
walls,
bricks-
how thick these walls are?
See, these are 50 mil, and then there are 3 layers in it. 50, then 25, which is then 75, odd. So in total, I think 150 or 125, 30 के आसपास जो normal आपका brick structure होता है, it's the same width which we work at. Because the only thing is we divide it into, instead of just one component, there are 3 components.
Is there any cavity in between?
That is filled by XPS, extruded polystyrene. So that's basically we are insulating the internal because we are giving you air conditioning. Now you will lose that air, when we run the air conditioning, then we lose it out in. Otherwise, in the normal conditions, when we are not using air
In fact,
conditioning,
I felt that there's a great difference. I mean, बाहर बड़ा ठंड रहता है रात को, पर अंदर टी-शर्ट निकल पहन
that's what I'm saying. Considering both the extremes of the temperature which is there, so sometimes the delta is not working for you. The inside temperature and outside temperature, and the drop within day and night temperature. If it's utilizable, we'll utilize every possibility which is available.
I think there must be 4 to 5 degrees difference.
The temperature drops, how much it comes down?
No, inside the room and outside.
Outside, as I said, that we design it according to the human body requirements. So, for example, we try to place somewhere between 28 to 30 degree, which is a very comfortable temperature for you. So, whatever
This,
way we get it.
Wall insulation,
Ji.
is it permanent or it would be destroyed in due course of time?
No, these remains in the structure for 80 to 100 years,
So
whatever
that is
life.
full life of the
Yeah,
building.
full life.
ये grey चीजें क्या है?
These are the fly ash bricks.
I mean, are they just for aesthetic purpose or there's some?
No, definitely, see, certain percentage of fly ash bricks you have to utilize into your requirements.
Okay.
So, most of the time people try to use it and maybe bury it. But CSC because this is you understand that this is for a lot of people from CPWD, from NBCC or other construction agencies come and get training.
Yeah.
They need to understand that there are structural things which you need to
So this is parapet wall.
this is, yeah, exactly, the design on a parapet wall.
Yeah.
So that at least fly ash
And
could be
this
utilized
regular,
in this way.
regular brickwork is also fly ash bricks.
No, these are AACs.
Yes, okay, you just said yes.
So
Yes,
you got those bricks made here or you procured it from outside?
That's where the local. So we've done a complete survey to understand what all materials are available within the range of 100 kilometers from this site.
Yeah.
So what is very closely available, what is very far off available.
Yeah.
The first experiment was with rammed earth.
Yeah.
Because we wanted what is there on site with
Yeah.
us. But when one on the site thing could not solve the complete requirements,
Yeah.
then we started moving little out of our boundary to see. The AAC is all, when you travel from Gurgaon to here,
Yeah.
you must have observed there are a lot of AAC manufacturers which are around.
Yeah.
And AAC is now one of the very interesting material which is there in every state.
Yeah, yeah.
So it's like the upgradation of the brick, because
Yeah.
red bricks, it takes away a lot of
it
topsoil.
reduces load on a structure.
Load on structure and brings down the concrete amount,
Yeah.
the amount of concrete and the
Yeah.
steel which is required in the structure.
What about this ceiling?
See, wherever we have ceilings which are usable, where you are going to have public gatherings.
Yeah.
So they have been laid in a different way, but where we are not, for example, those roofs or these roofs, these are all reflective roofs.
Okay.
So all the broken tiles, the white tiles.
Yeah, yeah.
So when we go back onto the gym, maybe once we get access to that roof, you will
Could
be
you
able to see.
explain this reflective principle? What do those tiles do?
See, what it does is, like, most of the time when the sun rays gets in, just material absorbs something and then it pushes back. So the change in the wavelength sometimes may or may not be able to, and plus two surfaces needs to exchange the heat between each other, right? So the white becomes one of the very important colors because our glaciers are white. Why?
Maximum reflection.
So absorption is very low.
Yeah.
So when you absorb heat, it goes into your structure. So you're reflecting more, you're absorbing less. So you're trying to make the environment inside into the structure much more comfortable in that.
So I imagine this is not a very expensive technology.
No,
And it used to be there earlier, but now you hardly see it in new buildings. Like, why is that?
See, that is where the tradition has been lost, and we have to bring that into the mandate.
Because
So-
the ACs are so easily available to install, people do not bother about reducing
Preventing
the heat.
yeah.
it's all mechanization sometimes.
But white ceramic tiles, do they have a role in winters?
See, when you look at typically in a winter environment, what is happening in, as I told, we are trying to make the comfort which is there in the structure retained with you for a very long time.
Yeah,
So heat is already there with you
yeah,
from various other elements.
Yeah.
So the building envelopes now restricted. For example, when you go to Himachal or something, would you like to prefer have windows which are like very big one, and so that you can get more enhanced sun which can come in, right? That
yeah,
is like a normal thinking.
Yeah.
But mind it, it gains and the loss are equal.
Okay.
So moment the glass, if it brings more heat, it actually takes out the lot of heat in terms of escape of the heat is
Yeah.
both ways.
Yeah.
So when you have in winters the heat is inside, it will escape out faster.
Yeah.
In summer it will come more in faster. So you have to look at what is the assembly you are trying to use. So that way is
But white ceramic tile color is
Right.
of no use in winters.
so for example, there are, as I told you, there are certain roofs which are not to be used, like where we don't walk or where we don't go. Otherwise, the normally these are being used.
Yeah.
So then if I would have in classroom, then I'll give you more. See what happens is when you look at the sun path, which is in
21, 22.
26, 27. On outside temperature is minus.
Yeah.
So when you sit on the window, what happens to you? In that temperature condition में जब window बैठते हैं, आप sun को झेल नहीं पाते अपनी बाजू. That's the radiation. Right. That's the form of the electricity. तो हमें रूप से तो काटना ही काटना है, चाहे वो विंटर और समर हो, उसमें कुछ चाहिए नहीं है. हमें जो आपको चाहिए, आपको तो हीट चाहिए, सन से डायरेक्ट चाहिए. तो आपको विंटर्स में मजा आता है सन में डायरेक्टली बैठने. वो फंक्शन हम नहीं कट करते. ये वो साइज है पीजोमीटर 1 number 1. This black box is the where the piezometer for groundwater.
Yeah. Okay. We have to run a little faster. Come this side. So, what you are looking at is a portable biomethanation plant, or you can call it a biogas plant, as popularly known. And it is basically a re-engineered version of a rooftop HDPE tank that we all have in our houses, right? So it has got two parts. The bottom part is where basically the waste is held, and the top part is this is completely floating, right? It's floating on water. So when you see the top part is rising, then you are rest assured that you have gas inside it, right? Now how does it work? It's very simple. You have to keep feeding organic waste, food waste, that could be vegetable peels or food leftovers from your kitchen. You can also add your garden waste into this, right? But garden waste must be dried garden waste and not kacha. So this is a 1 cubic meter capacity. I'm not getting into the detail of it. This
What
technology
this
was-
machine is called?
This is called this is a biomethanation plant, portable biogas plant you can call it. Okay? So this is a very cheap, in a sense that this product can be purchased for as little as 15 to 30,000, 35,000, depending on who is making it. This was basically popularized by government of Kerala back in 2014 when Swachh Bharat Mission Phase 1 kicked in. So so basically the principle of waste management hovers around 3 R's. The first R is reduce. So this is basically in compliance with the principle of reduce. Because the waste that we generate in our houses, I mean, just to give you a ballpark figure, the generation is about 300 to 400 gram or 500 gram per capita per day. And out of the 300 gram that we generate, about 60 to 70% of it is only food waste. And the problems that you experience all around you is just because of it is dry waste mixed with food waste. If you don't put your food waste over there, your half of your problem or most of your problems are gone, right? So this is one of the best ways to manage your food waste within your premises. You are standing a couple of feet away and you can't smell anything. There is absolutely no foul odor, and there are 3-way benefits. I'll tell you how. So this machine, it's a small unit. So it can, the quantity of waste it can hold. It can according to that it can generate gas equivalent to say a single burner stove which comes with this package, and it can burn it for about 40 to 45 minutes, right? So what our kitchen colleagues does, they exhaust this gas and then they switch to the traditional LPG, right? And this way we save around 5 to 6 cylinders a year. So there's a clear, monetization that you can see around it. Second advantage, when the gas goes up and it is basically taken out by the pipe, you are left with a slurry kind of a thing, and the slurry is completely digested. Even if you put the slurry and leave it on the ground, no flies or mosquito is going to touch it because their foods are gone. It has been eaten by it, and it is one of the best organic manure that you can ever imagine. You can straight away apply this to your courtyard or rooftop garden, and this is you can see it. I mean, I guess we have colleagues from Kerala. So Kerala, this is a very common practice. Even if you see a BMW parked in the courtyard,
how do
that
you-
guy is having something like this in the house.
How do you extract the manure from it?
See, you don't have to extract anything, right? You have to. There's a feeding there's a feeding inlet on the other side. You can see it from there. So you have to keep feeding. So the feeding capacity is about 8 to 10 kilo per day. So we had to do an estimation of how much food waste do we generate from the kitchen, right? It could have been bigger, but we also have a compost unit, so we didn't want to make it a huge unit and then the composting unit is basically starving for waste. So we did the calculation and we found that 1 cubic meter, you can add one more or couple of more units going forward if the quantity increases, but that's not how we are looking. We wanted to have a model so that people can understand the principle of it and the benefits of it. So the gas goes out, and this is basically how this slurry comes up, right? The maintenance is once in 2.5 to 3 years, where basically you need to stop feeding. You have to lift this floating dome, and you have to clean it and dry it for a couple of days and reinstall it. It's just like a child's play.
Is that a plastic one?
These are all plastic.
All of plastic.
Yeah. If it is empty, you can hold it yourself. I mean, you can lift it yourself. It's so light.
It can be smaller given the waste.
Yes, it can be even smaller.
How many gas cylinder?
Yes. See, cow dung, if you have cattle in the house, 6 per annum, per year.
Per year, 5
Yeah,
to 6
5 to 6
LPG
cylinders.
cylinders.
So your investment is just to buy this thing. So we bought this thing for about 20,000, right? So that's your one-time investment. And then all your waste is...
It is closed.
Sorry?
Where did you buy it?
There's a site promoted by Government of India. There's a ministry for new and renewable energy, MNRE. So you go to MNRE's site and you will get basket of such technologies available. So these are getting modified more and more. Yeah.